Now here's another problem that we are going to formulate into recursions. So in this problem, first we see that we have the demand of RT kilowatt hours of generating capacity for the year T. So the plant must decide how much generating capacity should be expanded every year. What is interesting here is that it may also reduce the capacity. So here X can be also a negative number. So if X is positive, it means you expand the capacity or add the capacity. If X is negative, then it means you reduce the capacity, and it's both possible. And then the next thing here is that 10% of the old generating capacity becomes obsolete and unusable. However, the capacity that you just built during this year does not become obsolete. Okay, so whatever you built this year is still okay. You can use it until the next year with the same amount, but whatever you have at the beginning of this year, 10% of them becomes obsolete and unusable. And the objective here is to minimize the total cost of meeting the power requirements for the next T years. As usual, you may want to pause the video to read this problem really carefully before you continue, okay? Same as before, we start formulating the recursions by thinking about aspect 1, 2, 3. So in aspect 1 is what are the allowable decisions? Our decision is to decide how much generating capacity should be expanded. So what are the allowable values for xt? Xt is the amount that we expand the capacity. Well, obviously, because the requirement for year T is RT, it means that whatever we have at the beginning of the year, let's denote it with IT, plus whatever we add or decrease this year, xt, it must be greater than or equal to RT, or the demand of this year, right? So let me repeat, whatever we have at the beginning of this year, denoted by IT, whatever we increase or decrease this year, denoted by xt, it must be greater than or equal to the demand, RT. Okay, and then you move around the terms, you get xt greater than RT minus IT. So that is the aspect 1. Now for aspect 2, because the objective is to minimize the total cost, let's look at all the costs that is incurred during the year T itself. So the activity that we do or the decision that we do in the year T is adding xt kilowatt hours capacity. Okay, so the cost is for adding that capacity, CTXT, plus we have the maintenance cost. The maintenance cost applies for the capacity that we already have at the beginning of the year, IT, plus the capacity that we add during the year, XT. So the maintenance cost applies for IT plus XT. Remember that the value for XT itself may be negative, but here, because we don't know whether it is positive or negative, we just write down IT plus XT. And it's okay if XT is positive, we will have IT plus something. If XT is actually negative, we will have IT plus a negative amount, or in other words, IT minus that amount. In aspect 3, we care about the state at the beginning of the year T plus 1. So at the beginning of year T plus 1, we need to know how much capacity we have, because the state here is the capacity that we have at the beginning of the year. So at the year t plus 1, we will have 0.9 times IT, because we see that 10% of the capacity that we have at the beginning of year t will become obsolete and unusable. In other words, only 90% of them will be usable in year t plus 1. However, the capacity that we built at year t, xt, that is still okay to be used for the next year. So at the year of t plus 1, we will have 0.9 IT plus xt. Okay, again, because 90%, only 90% of the IT may still be used, but all the xt is still okay to be used next year. So next year we will have 0.9 IT plus xt. So here's the recursion function for the stage big T. So this is the very final stage. That's why you don't see ft plus 1 here. So ctxt is the cost at year t from increasing the capacity by xt. This is the maintenance cost which we will pay from maintaining whatever we have at the beginning plus whatever we built this year. And then this is the allowable decision. So this is to ensure that we have enough capacity to satisfy the demand at year t. And then among all allowable possible values of xt, we'd like to find the one that gives us the minimum cost. That's why we write down xt here under the word minimum. And then FTIT means the minimum cost from year t until the end of the problem if at the beginning of year t we have IT capacity. So let me give you an illustration for the aspect 1, this thing here. For example, we know RT equals 100, so the demand is 100. We know that IT equals 85, which means we have 85 capacity at the beginning of the year. Then if you calculate RT minus IT, it means that we need to expand the capacity at least 15 or more than that. Less than 15 is not allowable because we have the demand of 100, but at the beginning of the year we only have 85. Let's see another example. If we already have the capacity, if we have the demand 100, but we already have the capacity of 108, it means that xt is greater than or equals to minus 8, which means that you may reduce the capacity as much as 8. You may reduce the capacity minus 7, minus 6, minus 5, minus 4, and so on. So any decision is okay as long as it is greater than or equal to minus 8. So minus 9 is not allowable, but minus 8 or bigger than minus 8, which is minus 7, minus 6, and so on, is allowable. So this is how you make sense of this inequality. So let's move backward to stage small t. So this is all the stages before the big T. So FTIT is the minimum cost from year t until the end of the problem if at the beginning of year t we have IT capacity. So we break this down into the year t itself plus t plus 1 until the end of the problem. So CTXT is the cost from building XT capacity this year. And then MT is the maintenance cost, which is the function of what we have at the beginning plus what we built this year. And then for XT plus 1, the state becomes 90% of what we have at the beginning of year T, we may still use it, plus what we built at this year, XT. So at the beginning of the year T plus 1, we have 0.9 IT plus XT. And then among all possible xt that we may do or we may decide, we pick the one that gives us the minimum cost. That's why you write down minimum and then below it you write down xt. So this is the summary. We define that the stage is year, from year 1 to year t. The state, this is the state, is the capacity that we have at the beginning of year t, which is denoted by it. And the decision is how much capacity that we increase at year t. And these are the recursions. Do not forget to write down the allowable decisions or the aspect 1 for each of the recursion. So that's the end of this video, and then in the next video we're still going to look at another problem with another characteristic. So see you on the next one. Thank you.